Wabarakatuh. A very good morning to everybody. Okay, so we start this beautiful morning with beautiful So okay, at the end of the class, you could explain from these lectures the meaning of word simple, linear, and in the simple linear regressions, what is the difference between linear and nonlinear? The least square methods, positive and negative linear relationship, interpretation of A and B, what is the meaning of coefficients of determinations, and the hypothesis about this test and interpretation by using SPSS. Okay, so simple linear regression, we start from simple regression and linear regression. Okay, for simple regression, okay, I want kejap tak jadi. Saya nak buang bawah ni. Alah. Okay, the definition of simple regressions, a regression model is a mathematical equation that describes the relationship between two or more variables. So this is about relationship between two or more variables. So a simple regression model includes only two variables, one independent and one dependent. That's why we call it simple. Okay, the dependent variable is the one being explained, and the independent variable is the one used to explain the variation in the dependent variable. Okay. Regression analysis is helpful in assessing specific forms of relationships between variables, and not only relationship between two variables, but you employ regression analysis to predict or estimate the value of one variable corresponding to a given value of another variable. This is the special of regressions. Not only you can look the specific form of relationship, but you also can predict and estimate one variables. Okay, so this is everyday example. This is the examples in regressions. Okay, an economist can estimate the amount of change in food expenditure due to a certain change in the income of a household. Okay, so they want to know if we increase the income of a household, what happened to the food expenditures of a family? Okay. A sociologist may want to estimate the increase in the crime rate due to increase in unemployment rate. Okay, they want to increase the crime rate. Alright. Do you have any examples by using this simple linear regressions? Anybody want to share? To predict what? Maybe your research? You want to estimate anything? Anybody?
Is the longer PKP makes you heavier?
Yeah. Okay, longer PKP make you heavier. Okay. So heavier means your berat, or maybe your BMI or your weight, and the longer PKP means the time, so the durations. And okay. Other than that, any?
There are some in the chat box, Doctor.
Oh, chat box. Oh, saya kena keluar lah ni. Sekejap, mana chat box? Nyala chat box dia. Post dekat mana? Sini. Okay. Does increase smoking increase risk of lung disease? Yes. Good examples. Dashni. Okay, Ravina. Hi Ravina. Jumpa lagi. Estimate stress level. Hi. Estimate stress levels of workers in the upcoming years. Estimate tu one variable ada dah. Tapi the other variables apa dia? Kan estimate stress levels ada. This is one dependent variable in the coming years. Maybe dengan another variables. Macam ni, yes, smoking is one variables, disease is also one variables, another variables. Okay, other than that, tak ada. Alright, good. For the introduction. Okay, so simple regression model includes only two variables. Okay, one dependent and one independent. So independent variables is X, dependent variables Y. Okay, so we have multiple and simple. Okay, so if one variable or one dependent and one independent, we call it simple regression. Okay, so this is another way to explain what is independent and dependent. Okay, so independent is the one thing you change, limit to only one in an experiment. Okay, dependent is the change that happens because of the independent variable. The example of dependent is height or health of the plants. Okay. Independent is the liquid used to water each plant. While control is everything you want to remain constant and unchanging. Okay, you have types of plant use, pot size, amount of liquid, soil type. This is the control variable. Okay, so this is for plant, but if this is human, okay, if you want to the height of children, if the height of children is dependent, so independent is maybe the nutrient, the intake, the dietary intake, the physical activity, the environment, maybe the supplementations or what the vitamin intake can influence the dependent variables. Okay, so linear regressions is a straight line relationship between two variables. Okay, the term regression was first used by Sir Francis Galton, who studied the relationship between the heights of children and the heights of their parents. Okay, so this is linear. Okay, if you plot the Y and X, food expenditure and income, when you got this line, so this is a linear relationship. But if you got this line, so this is non-linear relationship. So actually you have to plot a line before you run this regression. If it shows that non-linear, so you cannot use the regressions analysis. Okay, so plotting a linear equations. Okay, this is examples of one equation, y equal to 50 plus 5x. Okay, so these equations is this line. This whole line is y equal to 50. The intercept at y, 50 plus 5x. Okay, so x 5. So when x equal to 0 here, so y equal to 50. So this is one dot, okay, 1 point. And then another one, when x equal to 10, so y will equal to 50 plus 50, 100. So this is another plot. So you can you can draw a straight line here to show that this is the line for y equal to 50 plus 5x. Okay. Okay, this is a non-linear pattern with outliers. But for some reason, I'm very happy with the data. Okay, some comic Okay, all right. So with these equations, y equal to 50 plus 5x. Okay. If x equal to 10, if x equal to 10, put inside the equation, so y will be 100. If x equal to 11, then y will become 105. So this means if x increase 1 unit, then if x increase 1 unit, so y will increase 5 units. So this is the basic of the regressions where you can predict one variable with using another variables. So in here, if x increase 1 unit, so y will increase 5 units. And it is all same in these same straight lines. Okay. Okay, in here, 1 increase 1 unit of x, the y will increase 5. And here's also the x increase 1 unit, the y will increase 5 units. Okay. Alright, so this is the equation in simple linear regressions. Okay, y is dependent variables, a is constant terms of y-intercept. That means if x is 0, so y will be equal to a. Right, plus b and x. X is independent variables and b is slope. B slope. So x independent variables. Okay, so in the regression model, okay, for populations, you take your sample to infer populations. Okay, actually in the populations, the equation is like this: y equal to a, the big A plus B, the capital letter of A plus capital letter of B, Bx plus E, epsilon. Okay, actually this is the random error. The random error term, this is all the missing, the omitted variables, the random variations is all inside here. Okay, y dependent, x independent variables. So what we want to look at is the b value, because it is the slope. Okay, in the model, y hat, y in sample, you take a sample to infer for populations. So samples is y hat equal to a, small letter, a plus bx. A and B, which are calculated using sample data, are called the estimates of A capital and B capital respectively. Okay, so this is examples. Incomes in $100 and food expenditures of 7 households. Okay, 7 households. This is their income. This is for expenditures. Okay, a plot of paired observation is called a scattered diagram. Okay, so this is scattered diagram. Okay, so you plot 55 and for expenditure 14. So this is income, the x income, the y for expenditure. Okay, 55 here's. Okay, there and there. For expenditure 14 here. Okay, so this is one plot. First household, the 7th household, 67th and 17. So they plot. Okay, so this is scattered diagram. Right. So you can from the plot you can draw many lines. Here. Oh, so many lines. But you have to search fits a straight line to this messy scatter plot. So X is called the independent or predictor variable and Y is the dependent or response variable. Okay, the regressions or prediction line has the form of Y equal to A plus BX. So macam mana nak cari ni? Wow, there's so many lines you can draw. Alright. Excuse me. Okay, so what you have to do in the SPSS, by using SPSS, what they predict is this one, the regression line and random errors. Okay, random error for the sample regression model is denoted by E. E means actual food expenditure minus predicted food expenditure equal to Y minus Y hat. Okay. So this straight line is the predicted. This is the predicted food expenditure. This is food expenditure. Okay, so the actual food expenditure is the dot one. Oh, the actual, this one. This one, this one, this one. So between the actual and predicted, so this small line, this vertical distance, this is all the error. This is all the random error. So the least when the error is squared, so this is the smallest, where give you the smallest error. So this is what we call least square method, because the error is squared and we total all the square. So this least square method. Okay, a way to determine the equation of the line that provides a good fit to the points. Okay, so what the error means when, okay, this is the predicted 1690. Yeah, from these equations, the predicted is hit this one, but the actual one is 1600. So this is the error. Okay, all right. Can't you now? Can you draw the scatter plot for this sugar and calories? The information on amounts of sugar in grams and calorie count in one serving of a sample of 7 varieties of Kellogg's cereals. Can you draw it now? I give you 2 minutes. So you must have Y and X. Y is calorie and X is sugar. Who finished can take the picture and send to Telegram. We look it at Telegram. The Telegram, somebody's send your pictures. Are you still with me?
Yes, doctor.
Okay. I'm not talking alone.
Hello, doctor.
Yes.
We can see your the data link. Can you open the Telegram?
Right. Nak tengok Telegram. Okay, lupa. Dah ada. Nazmi. Okey, kita tengok. Nazmi Zakaria. PhD Wow. Yes, positive linear. Hai. Jumpa lagi. Good. Wow. Terus ada Y, the equations, the R squared here. Okay. Thank you, Nazmi. Okay. Other than that, the hand sketch. Wow, Ravina. Okay. Good. Nice. Excellent. Pun guna apa ni, key in terus dapat the equations R squared. Okay. Ni semua PhD student ni. Tu laju. One more. Looking for one more. So it is a positive regressions. Positive linear regressions. Mardia, yes, okay, the hand sketch, right. Good, excellent, excellent, everybody's excellent, okay. Congratulations. Alright, so, yang mana ni? Okay, draw scatter plot, okay, you have already draw scatter plot. Write equations. Okay, this is when be given. Okay, maybe in your exam, you cannot use, if you are not cannot use the SPSS. Oh, another one, Shahid want to show. Okay. Yeah. Okay. Excellent, Shahid. Thank you. Okay.
Thanks, teacher. Thank you.
Welcome. Okay. Okay. This is maybe the way that we can give you questions. We give you, okay, given A is what, B equal to what, and then you can write the equation from there. Maybe draw scatter plot, and maybe, okay, estimate the calorie count for a cereal with 50 grams sugars. So you have to know, okay, sugars by where, Y or X. Okay, sugars is X. So 50 plus here, 50 plus times with 18.5, and then plus with A, 9.4. Okay, all right. So this is the scatter plot. This is the R. So calories, we insert the 50 inside times with 18.5. So this is the predicted calories. Okay, so the interpretations of A. Consider a sugar with 0 gram. Okay, using the estimated regression line obtained in examples. Okay, when if the sugar is 0, if the sugar is 0, so your calories is equal to 9.4. So thus we can state that a calorie of cereal is expected to be 9.4 if sugar is 0. It seems like when you want to predict maybe BMI. Okay, so BMI here, and maybe this is the values of 20 plus all the independent variables. Okay, when the independent variables is 0, so your BMI is equal to 20. It start with 20. Okay. The regression line is valid only for the values of X between 2 and 10 gram sugar. Okay, you actually cannot predict more than, cannot extrapolate the line. So when the line is by using 2 and 10 gram, then it's valid for the range of that value. Okay, for interpretation of B, okay, the value of B, this is the slope. In the regression model, give the change in Y due to a change of 1 unit in X. Okay, we can state that on average, 1 unit of sugar increase in cereals will increase the calories by 18.5. So this is when you saw the B, okay, you can straightly say that the increase of the independent variables will increase dependent variable as that value, the B value. Okay, so this is positive, this is negative, positive, negative, a linear relationship. Okay, quotients. Okay, in real world, relationship between two variables may not linear. Okay, so maybe like this one and this one, yeah. So that's why you have to construct the scattered diagram first. If the diagram is scattered diagram is like this, so this is non-linear relationship. Okay, so when it comes to regressions, you it is about coefficients of determinations. Coefficient of determination is how good is the regression model, or how well does independent variable explain the dependent variable in the regression model. Okay, so actually this is the formula how to get the R square. Okay, for population denoted by rho square. Sample is R square. Okay, so the R square should be between 0 and 1. Okay, so the hypothesis testing about this B, the B is slope for regression line. Okay, so from this equation, y equal to a plus bx. Okay, hypothesis now, the b equal to 0. That means slope of the regression line is 0. And where x does not determine y, the regression line is no use in predicting y for a given x. So this is the hypothesis now. Okay, for hypothesis alternative, okay, the b can be 3. It can be 3. Whether b not equal to 0, that means that you don't know which one is it positive or negative. You just said that okay, x determines y. Or it can be the b more than 0, where the x determines y positively, or b less than 0 means x determines y negatively. It can be 3 of this hypothesis alternative. Okay, so this is one of examples. I think this is about the total calories. Okay. No. I didn't give you the examples. Okay. All right, this one. A researcher is trying to predict full-scale IQ by the total calories intake of the adolescents. Okay, so full-scale IQ, this is by using a Wechsler. The instrument is called Wechsler. And total calories in diet intake by using the dietary intake recall. Okay, they want to predict the IQ by the diet intake. Okay, so this is how it should be like this. Your data should be continuous. This is all the continuous. The full scale IQ, 92, 70, 100. Okay, this is the continuous or the scale of the data. Okay, another variable also should be continuous. Independent is continuous, dependent also continuous. So simple regression is used to describe relationship between these two variables. One is the dependent variable, the other is the independent variables. You will need two columns of data. Okay, one column will be used to predict the other. So we will predict IQ by dietary intake. Okay, so in the SPSS, select linear, analyze regressions. This is an analyze, and then regressions, and then click linear. Okay, so in this page, dependent. So you have to know what is your dependent variable. So in here is IQ, full scale IQ. Independent variable, there are many independent. So I put in here the only one because this is simple linear. So calorie, I input here calorie. So I click OK. And then this is the results. Okay, the R square value here give the proportions of variance that can be predicted by the regression model. Okay, so this is the reported, the commonly reported is percentage. So 0.151 means 15.1%. Okay, the adjusted R square values give this is the proportion of variance that can be predicted using the regression model on the new set of data. So 14.7%. Okay, what you should present in your result is this one. This R square, not the adjusted R square. Okay, this R square, 15.1%. Okay, the R value here indicates that as calories increase, the full scale IQ score also increase. So this is the positive correlations. So actually, the R square is from the correlations value. Right. Mission denoted by R square represent the proportions of total sum of square, show the amount of variance in dependent variable that can be explained by the independent variable. So in the percentage. Okay, so what you can write when you got the result of R square is 15.1% of the total variation in full scale IQ of adolescent occurs because of the variation in their calorie intake, and the remaining 84.9% is due to randomness and other variables. So there are many variables. So this is 84.9% of that. Okay. So from here, okay, so this is the important results. Okay, the coefficients. Okay, this look at here. Okay, this is your this is the dependent variables. Okay, this tenaga calorie, and this is the calorie is your independent variables. Okay, look at this SIG. Wow, significant. Okay, the p-value SIG for each component is given this column. This is the significant. Okay, that's mean your calorie, it significantly can predict your dependent variables. And the value is this one, 0.01. Okay, this is from here, unstandardized B, you write your equations. So IQ equal to 80.262 plus 0.01, your calorie intake. Okay, so this is your equations. All right, so from here, okay. The T value for constant is significant. The T value for calorie, okay, regression significance. Okay, so the increase of 1 unit of calorie will increase 0.01 full scale IQ. When you put inside here the calorie, okay, 1, so 0.01 1. So when the calorie is 1 unit, so your full scale is when the constants remain constant. So plus 0.01. That means increase 0.01. The full scale IQ increase 0.01 when the calorie is 1. But when calorie is 0, times 0, 0 lah. The full scale will be 80.262. So the intercept is 80.262. Okay. So, all right. Exercise. Okay. A researcher wants to investigate what is the variable that predicts total cholesterol. Okay. Okay, this cross-sectional study was conducted among 250 subjects in KL. Okay, the variables collected were total cholesterol level and frequency of eating fast food in a month. Okay, answer the questions below according to the expected output of the analysis done by the researcher. Okay, all the assumptions for the test are not violated. Okay, so state the statistical test used in this study. Okay, give 2 reasons. Okay, can you answer and maybe you can write in the chat? State the statistical test used. Give 2 reasons. A. B. Oh, that's supposed to be B. Okay, state the dependence and independent variables. I'll give you 1 minute. Or you can you can say it verbally if you don't want to write. These are examples of your exam questions. They give you scenario. Okay, so what is the clue that we can have from these sentences to show that this is what test?
Can I try, Doctor?
Yeah, who is it?
Sharifah.
Okay, Sharifah.
We can use linear regression.
Okay.
And the dependent variable is
Okay, you should write full. Simple. Is it linear regression or is it multiple or is it simple or is it
simple.
okay, simple. Linear regression. Okay. Alright.
And what was that?
Two reasons.
Reason because it only has 2 variables.
2 variables. What is it?
The frequency of eating is independent.
Betul.
And the total cholesterol is the dependent.
Yeah, okay. So that is one reasons. You can write okay, 2 variables. You should write independent. What is the independent? What's the dependent variable? Okay, 1 marks for that. Another point, another reason. Other than Sharifah.
Okay.
Okay. Give chance to your friends.
Doctor, can I try?
Okay, who is it?
Kasmawati.
Kasma, okay.
The another reason is to predict. Is it?
Yeah, correct. Okay. To predict, the word predict. Yes. It shows that it should be simple linear regressions. Okay. Congratulations, Kasma. Other than that, you want to give extra schema for these answers? Can?
Morning, Doctor.
Morning. Who is it?
Maybe because of the assumption are not violated. That is can be one of the reason.
Assumptions Assumptions tu tak kuat lah. Kalau tak tulis tu, then you can answer what. Boleh lah itu. Okay, that one the last in the schema. Okay. Yeah.
Can I try, Doctor?
Okay, who is it?
Rohaya.
Rohaya, yes.
Because the total cholesterol is a continuous data.
Yes, correctly. Yeah, continuous. Your total cholesterol, your dependent variable is continuous data. Right. Okay. Alright. Okay. Number B. State the dependent. Okay, dah jawab kan? Dependent, independent dah terjawab. Your food frequencies. Your independent cholesterol is your dependent variables. Okay. Alright. So from here, state the equation for the study. And state the coefficient of determination value and briefly explain what it means. Equation, okay, write the equation.
Is it y equal to a plus 0.298x?
Okay, y equal to
0.298. 0.25, sorry, 0.25.
0.25. Mana 25 tu? Bukan. No. Zero 0.25 is your R square.
We are looking for the slope.
Slope. So what is the slope? From the B.
Oh, 5189.
5.189 plus
0.142x.
yes, betul. Okay, y equal to 5.189 plus 0.142x. Okay, for the full, you should write what the first line may be that y equal to that x. The second line you should write y equal to total cholesterol. So total cholesterol equal to 5.189 plus 0.142 in the bracket food frequency of food intake, the fast food intake.
We must write in full, Doctor.
Yes. Okay, so number B, state the coefficient of determinations value from the study. Coefficient of determinations. Where? Which one?
5%.
Yes. What?
So the only 25% of frequency of food, fast food intake consumption will estimate the cholesterol level.
Yes. Wow. Okay, congratulations. Who is it?
Omchi, Doctor.
Omchi. Patutlah. Okay. Okay, thank you, Omchi. Okay, that's correct. Absolutely correction. Absolutely correct. Okay. The R square is 25%. So the influence of frequency of eating fast food is 25%. Influence your dependent variable, influence your total cholesterol. Other than 75% is other variables that you not studied. And it is significantly can predict your total cholesterol. Alright, okay, last. Calculate. by this one by using the same equations. We given you the gender, age, ethnic, the frequency of fast food. So in your examples, the only data that you have is the frequency of fast food. So for Raju, y equal to 5.189 plus 0.142 times 11, and for Putri 5.189 plus 0.14 times 6. Okay. Alright. So lastly, you have report all the finding according to APA style. Okay. So the conclusions here. Regression analysis is employed to predict or estimate the value of one variable corresponding to a given value of another variables. Okay, I think we have another 2 topics to discuss this morning. So this is the conclusion for simple linear regressions. Okay. You want to break for 2 minutes, taking stretch. Stretchable. Yeah. You have questions for the regressions? Ada soalan ke about regressions?
Doktor, saya ada soalan.
Ada soalan, yes. Siapa ni?
Saya Nazmi.
Ya, Nazmi, yes.
Doktor nak tanya, R square tadi ada, dia mention about R square. R square, is it the same with raw? Raw is a symbol name or?
Raw is the R.
The
Raw.
R.
The R for populations we call it raw.
So the symbol is different lah.
Simbol ni lain. For population ni raw, but for sample R.
R square.
R square.
Alright. Thank
Kita
you.
tak dapat. It is very apa ni? Impossible kita dah dapatkan row sebab row population kan. So R, okay, we can get R sebab we can get the sample. So when we explain, we use R. We don't use the row.
Alright.
Row ni macam background, backstage punya di belakang tabir, kan. Alright.
Alright, thank you, Doktor.
Welcome.
Doktor.
Yes.
But if you want to ask Sharifah.
Sharifah.
But if you requested us for the population, we can still calculate from this table, right? Because you are giving us the standard error of estimate.
Estimate. For populations, if I have the error, if I give you the error, then yes, you can calculate the row.
Is the standard error of the estimate on that right column, the most right column is it's not an error sum of square, Doctor? That one?
This one?
Yeah.
Saya jarang guna lah. I'm not using these figures. Kita jarang guna row tu. We use the R square. Yang ni kita tak guna. We don't use this.
So we just use the R square just now.
Yes. The R squares. Buka pintu. Okay.
Doktor, saya Datul here.
Yes, saya Datul.
Doktor, can you go back to the exercise before for the R square? How to explain again, Doctor? For
This
the R square? Yes.
Okay. The variations. Okay. The variations in total cholesterol is 5% can be predicted from the variations in frequency of eating fast food per month. Boleh? The variations in total cholesterol is 25% can be predicted by the variance of frequency of eating fast food per month.
Alright, thank you, Doctor.
Welcome. Linear correlations, coefficients. Okay. We measured the linear relationship between two quantitative variables. Okay, paired sample data, bivariate data. So this is the same family with regressions. Correlation same family with regressions because we measure we measured relationship between two quantitative variables. But the difference with regressions, because regression you can predict or you can estimate one variables from another variables. But in correlation, we just want to look the closeness of two variables, the relationship between two variables. Or we can state in the objective, your special objective, to determine correlation between this and that. So that is your specific objective, to determine correlation between this and that, between two variables. Okay, so measure the relationship of closeness between two variables. Okay, measure the strength of the linear association between two variables. And for population data is denoted by rho. For sample data is denoted by R. Okay, so the value of R can be lies between -1 to 1. So this for populations and for the samples. Okay. So remember, it is the relationship between two variables, and you can measure the strength. Is it strength relationship? Is it strong? Is it medium, moderate, or is it low or weak correlations? All right. Examples. Okay. The more time you spend running on the treadmill, the more calories you will burn. Okay. Taller people with larger shoe size and shorter people have smaller shoe size. The longer your hair grows, the more shampoo you will need. So this is maybe same like the regressions. We have two variables. Okay, so this is perfect positive linear correlation, R equal to 1. This is perfect negative linear correlations, R equal to -1. So R0 means no linear correlations. Okay, so maybe in your research, in your master or PhD, your data will be like this or like this. So this is strong positive linear correlation. So this is weak. The line should be more vertical. Okay, this is strong negative, this is weak negative. Alright, so a strong correlation means a small amount of error and most of the points lie close to the regression line. Okay, high values of one variable associated with high values of the second variable indicates the correlation is positive. One is high and another one is low, so this is negative. And range be from -1 to +1. Okay. So simple linear correlation coefficients denoted by R measure the strength of linear relationship between two variables for a sample. So this is the formula. Okay. The hypothesis testing about the linear correlations coefficients. Okay. Actually, this is the formula, but I'm not going to examine you these formulas. Okay, I'm just showing you. If both variables are normally distributed and the null hypothesis null dot rho equal to 0, then the value of test statistic T is calculated as this formula. Okay. So usually null hypothesis is linear correlation coefficient between two variables is 0. Okay, so this is null hypothesis, rho equal to 0. The hypothesis alternative can be either one. Okay, rho less than 0, rho more than 0, or rho not equal to 0. Yeah, so actually this is like for the regression, the rho change to the B capital, B capital. Okay, so we move on to the SPSS. Okay, so we have two variables continuous. Okay, so you if you heard from previous that I don't ever mention about dependent and independent in these correlations, because you don't need to identify which one dependent, which one independent. Okay, that is another difference between correlations and regressions. Regressions, you have to identify which one independent, which one dependent. But in correlation, no. You don't have to identify to determine which one is dependent and independent. We can choose two continuous variables. So I choose from here, may key in those two continuous variables. Okay, go to graph. Okay, legacy dialog. Okay, then in the scatter plot, okay, search for scattered dot and go for the simple and define. Okay. Okay, so this is the scatter plot. Okay, looks like okay. The shows maybe weak correlations here. Okay, yeah. When you double plot the dot, the dot, so this is the line. So R squared 0.04, so very low. The R squared is very low. Only 4% can predict the systolic. Oh, this is age. Okay, 4% of age can predict the systolic. But this is not about regression. This is about correlation. Okay. We go to the correlations results. Okay, actually in correlations you have two types. Okay, bivariate and partial. Okay, bivariate correlations. If you write bivariate Pearson correlations, you just studying relationship between two variables. But if you are doing the partial correlations, you have two variables, but you control the effect of third variable. Okay, this is the extra from bivariate. The partial correlation is extra from the bivariate because you can control the effect of third variables. So bivariate correlations is between two continuous variables. Okay, this is all the assumptions. Okay, it should be normal distributed, linear relationship ascertained, homoscedasticity, and two variables must be quantitative continuous data and independence. Okay. Alright, so we analyze, correlate, bivariate. Then you will get this this page. Okay, so more you key in the H and systolic in here. Click for the Pearsons. Okay, so this is the results, correlations. So H and systolic is 0.209. The p-value 0.04. Oh, significance. It's significance, but the R is 0.2. Okay. Here. So from here, this is only one results, not two results. This is the same. This is like mirror, like mirror. So you can write in your report only this one, only this. So age, umur mean age, Okay, the age and systolic blood pressures. Okay, the R value is 0.209, the P value is 0.041, and equal to 96. So this is weak correlation, the positive and weak correlation, but significantly, this is significant. Okay, some of you may be that there are many school of thought that you need to look at the significance. This is important to look at the significance. But some of the statisticians, they prefer to look at the R value. The R value is more important compared to significant, because the significance value, if you have very large sample size, maybe 1,000, only the R 0.1, 0.05, or they will show you the it is very significantly if you have very large sample size. Okay, so you have to be conscious to how to report your data. So for me, if I'm calculate, my sample size is enough, not very large, not very small, so I prefer the R value. I prefer to show the result of the R value. Is it low? Is it positive? Negative? Is it strong? Is it medium or moderate? Then okay, and it is significantly or not significantly from this p value. Okay. All right. And the interpretation of correlation, there are many cut-off points. This is one of the cut-off points. Okay, there are that 0.3 below is very weak. So in here, 0.39 below is weak correlations. 0.4 to 0.69 is moderate. This is strong. This is very strong correlations. You can choose which one. Okay, this is how you write the APA style. To assess the degree of association between systolic and age in 96 subjects, Pearson R was then computed. A significantly positive weak correlation was observed between these two variables. Significant, positive, weak correlations. So there are 3 or 4 information here. Significant, yeah, from P. Positive, yeah, there's a positive before the R values. Weak, this is from the value of R itself. Correlations, okay, from the R means correlation. So 4 items was observed. Okay, assumptions were unviolated. Okay, so precautions. It's simple in a regression and correlation. Okay, make sure the two variables are measured on the same entity. Not like the health of subjects. You want to correlate with the quality of air, of environment. Because this is not the same entity, but if you want to correlate between the health of a subject with the air that he wear, the measurement is from her instrument that from her. Okay, for example, there is one equipment instrument to check the PM, the particulate meter of air. This is for air quality. 2.5. Okay, there is instruments that you can wear it, so it can detect the quality of air. Okay, and then you correlate it with the heart rate of the same samples. That one can be measured. You can measure the correlations. Okay. Okay, this one height and weight are taken on the same individuals. Okay, usually does not make sense to speak of correlation between heights of one group of individuals and weights of another group. And no matter how strong is the indication of relationship between two variables, should not be interpreted as one of cause and effect. It can mean any of several things. Maybe X causes Y, maybe Y causes X, or maybe there are other third factor that causes both X and Y. So when you want to do the summary, the conclusions for correlations, you just can say that there is a correlation or there is an association between this and this. You cannot say that this one can affect this one can influence this one can the words of cause and effect is not, you cannot get it from the correlation, but you get it from the design of the study. If you are doing cross-sectional, no. But if you are doing the intervention study, experimental study, then you can say, okay, this is the cause and effect. Okay. And should not be extrapolate. Okay, here. Okay. Wow, very nice. But after you increase, it's the others, the Y will decrease. And this is will increase. So if your data here, so should not be extrapolate. Okay, so the conclusions. Measure of the relationship or closeness between two variables and measures the strength of the linear association between two variables. Okay, that's the conclusion for these correlations. Okay. Any questions? How to do the partial? I said that you have bivariate and partial. Okay, that one I will cover in the SPSS, the lab. I will show you. Any question from this topic? Yes.
Sharifah here.
Yes, Sharifah.
Doctor, when you said just now we cannot extrapolate.
Yeah.
I thought that's the one of the reason why we doing linear regression. This actually goes back to the linear just now. I thought that's the one of the reason why we are doing linear regression to extrapolate in the future. I mean, for the study that we are looking at. But what do you mean by we cannot extrapolate?
We have to be aware because okay, for example, you get the you take a samples, okay, 100 samples. So the BMI maybe you measure BMI. So BMI for that sample maybe from 18 to 30. So 80 to 30 only. So that one, so that's mean all the equations is for only for that range. If the samples is for the BMI is 40, so that one may be quite the outliers one, 40 or 38. So that one should be aware. Maybe the equation is not same like the equation that we produce from 18 to 30 values.
So means in research we cannot extrapolate, doctor?
You have to be aware, you have to be kena berhati-hatilah untuk dapatkan conclusion tersebut. To predict boleh, predict kalau yang biasa takut data tu tak termasuk dalam you punya populasi. Kan you have your inclusion, exclusion criteria, you take your samples kan. So, okay, this is inclusion, exclusion, okay, only for normal data. So, this equation is for normal data. Okay, this equation is not for the, okay, example, your samples is for a children's. Okay, this is equation is for children's. Then, if there's elderly, this not that, so tak fit for that equations.
I mean, let's say we stick to the let's say we are talking about BMI in children just now. BMI in children as per their what was just now, the income of the family. So if we still stick to the same children. The sample is the children.
Uh-uh.
No, my question is we cannot discuss the extrapolation in the like this, let's say in the discussion part. If we aware that the equation is fits for our study, but can we extrapolate or predict or beyond our sample, so means it's not valid doing such.
You can use that model. Okay, katakan BMI and income. Okay, BMI, your samples from your samples, your BMI is for children. Okay, for children, and income maybe for B40. B40. So if the result that you get, okay, 25% of official determinations. So 25% of these models can predict the BMI, kan? Okay, 30%. Okay, these equations is only for children and those income is B40. So kalau dia extrapolate tu maknanya kalau macam nak gunalah model ni untuk orang tua lah pula, untuk elderly lah pula. Tapi elderly yang kaya-kaya, those rich T20. Cannot, tak boleh because it will become not 25% anymore. So maybe itu dah jadi lain lah sebab
Now I understand because lately when we see when we read a journal article, sometimes they extrapolate data, so I thought I can rely on that. Means I have to read that with cautious. Is that, Doctor?
Yes, betul.
Okay, now I understand. Thank you so much.
Alright. Ada soalan lain?
Doctor,
Yes.
Atira here.
Yes, Tira.
I want to ask you, I still cannot really understand whether when do we use simple linear regression or Pearson correlation. Okay, for example, my research is about depression and suicide, which means depression is predictors for suicide. So do I use simple linear regression or Pearson correlation?
Okay, so suicide is from what? From the questionnaire? Is it from questionnaire?
Yeah, both from questionnaire.
Oh, continuous and continuous. Okay. Do you have any other variables?
Yeah, also anxiety and also stress.
Okay, so maybe what you should do, the first one, maybe your specific objective, the first one may be descriptive to measure the suicide level, depression, anxiety, and so on. The second one, you can write your specific objective to correlate between suicide, depression, and also on. Okay, because you want to know what is the strength, is there any correlations, is there any, is it positive correlations? Okay, number third, I think you should not the simple linear but multiple linear regressions. After this kan, kita punya lecture after this is multiple linear regressions where you can combine all the independent variables to predict your dependent variables.
For the correlation, do I use simple or Pearson correlation, Doctor?
Yes, you can use the Pearson correlations. The bivariate.
All right. Thank you, Doctor.
Welcome. Okay, 1/2 an hour for multiple linear regressions. Oh, you have any other lecture after this, after 11? Ada kuliah tak?
No.
No, Doctor.
Okay, so boleh boleh terlepas 15 minutes ke boleh
Okay.
Okay. Oh, we have other questions, discussions. Not sure.
All the slide is already packed in our folio, is it?
Oh, not yet. After
After
this.
Right, all right. Thank you so much.
Okay, welcome. Okay, multiple linear regression. So objective, okay, when is used to use linear regressions, SPSS, okay. So you can differentiate simple linear and multiple linear. What do you understand? Okay, never mind lah. I just terus je. Okay, multiple linear regressions, you use two or more independent. Okay, for simple linear, only one independent or one predictor. But for multiple linear, you have more than two or more independent or predictors. Variables to predict value of dependent variables. Okay, so this is two independent variables, A, y equal to A plus B1x1 plus B2x2. Okay, K independent variables, A plus B1x1 plus B2x2 plus plus BKxk. So you can have many independent variables. If you have 1,000 independent variables, or 100, it depends in your research. So, okay, relationship should be linear also. And what you interested in this multiple linear regression is equations. You interested in multiple regression equations. And this one, you have to decide which variable is dependent, which variable independent variables. So dependent variables are criterion variables, criterion, and your independent variables equal predictor variables. And this is compulsory. Your dependent should be continuous. Continuous. But your independent can be continuous and can be dichotomous also. Can be continuous and can be dichotomous. Okay. Regression analysis reveals relationship among variables but do not imply that the relationships are causal, not causal. Okay, so demonstration of causality is a logical and experimental rather than statistic. Causality is if you are doing experiment, then you can say this is the cause of this one. Okay, so what research questions you can ask from this multiple regression is this one. Okay, how accurately can something be predicted with a set of independent variable? Okay. For example, okay, tadi siapa? Tira ke? How accurately can suicide be predicted by depressions, anxieties, and stress of subject? Number two, maybe your research question can be like this. What is the relationship between a certain IV and DV while simultaneously control for confound risk factors? If you have many confound risk factors, for example, what is the relationship between suicide and depressions, anxiety, and stress while simultaneously controlling for age, controlling for gender, controlling for for the physical activity, from the nutrients, maybe all the confounding factors. Okay, so this is how you can write your research questions. All right, so multiple, okay. So same like simple linear regressions, the pointer here is coefficients of determinations, your R square. To measure the goodness of fit of the model, proportions of variation is independent variables accounted for by all the independent variables. The variations in dependent variables. Okay. If 3.6 0.36 indicate that 36% of variation in the dependent variable can be explained by variation in the independent variables. Okay, measure of strength or relationship between independent and the set of independent variables. Okay, if the value of F test, the ANOVA test, it shows that whether there is a significant relationship, whether the model as a whole is significant, or whether the R square is significantly different from 0. Okay, so in this MLR, the null hypothesis is the R square population coefficient of determination R square is equal to 0. That means no relationships. Okay, so the general consideration used to choose IV. Okay, if you have 100 independent variables, okay, do all the 100 of independent variables can be included in the equations. Okay, okay. First of all, regression will be best when each independent variable is correlated with dependent variable but uncorrelated with other independent variables. Ini pening sikit. Okay. So, antara between independent variables and dependent variables should be correlated. But between all the independent variables, not correlated with each other. Okay. Identify the fewest independent variables necessary to predict the DV, where each independent variables predict a substantial and independent segment of variability in the DV. Okay, alright. In the multiple linear regressions, there are many assumptions. The first is large sample size. Make sure you calculate the sample size. Okay, you have to look at the normality, linearity, and homoscedasticity. You have to look whether there are multicollinearity. And you have to make sure the predictor variable must be correlate with dependent variable. Okay, get rid if R less than 0.1. And make sure there is no outliers by looking at the Cook distance and Mahalanobis distance. Okay, look at one by one. Okay, for sample size, testing multiple correlations. Okay, this is I've taught you sample size calculation last week by using G power. Okay, so maybe by using G power is more accurate compared to this one. So this is only the rule of thumb. The rule of thumb. Okay, I have 10 predictors. So 50 plus 8 times with 10, 130. So the 130 is rule of thumb that you have to choose if using this formula. But for more accurate, you can use the G power. Okay, normality, you can look from box plot, you can look from stem and leaf plots, normal P and P plots, Kolmogorov-Smirnov. Okay, and for linearity, homoscedasticity of residuals, okay, you can assess by using normal P and P plot and scatter plot. Okay. Right, this one. This is a normal Q and Q plot. This is the scatter plot. Okay, so this normal P and P plot, this show normal distributions where all the lines, all the dot, the observed is in the straight line. The observed and expected is in straight line. Okay, while for scatter plot, it shows that this is residuals and this is the predicted. It is scattered all around, not no clear pattern. So this is showing the normality, linearity, and homostaticity. Okay, you can look at, there is no outliers here because there is no observation greater than 3 standard deviation. This is 3 standard deviation, 3 standard deviations. So no data more than 3 standard deviations, all inside this one. So there is no outliers from this scatter plot. Okay, about the homoscedasticity, these are examples of homoscedasticity between y and x. Yeah. But this is the examples of heteroscedasticity. It's small here and then bigger, larger. Okay, this one. Okay, so make sure data is like this. Right, another one is multicollinearity. When, okay, this is what I explained before. In multiple regressions, between the predictors, it should not be highly correlated between them. Between all the predictors, it should not be highly correlated with each other. Okay, for example, to predict suicide. Contoh I ambil contoh you ya. Okay, to predict suicide. So you have depression, you have anxiety, you have stress. Okay, so you have to make sure the correlation between depression and anxiety, between depression and stress, there is no highly correlated. Not highly correlated. Not highly correlation. No strong correlation between depression and anxiety. If it's happened, it shows that when you do the correlations, wow, depression and anxiety is 0.99. Okay, the solutions is here that you have to eliminate one of the variables, or maybe you have to combine them. Combine maybe by using a formula. I don't know how to combine, but the easiest way is to eliminate lah. Maybe the more important is depression. Okay, you choose depression, not anxiety. Okay. Okay, the value of R, if more than 0.9. If the correlation is more than 0.9, then you get rid that one of the variables. Okay, predictors variable can be correlated with each other as much as 0.8 before there is a cause for concern about multicollinearity. If 0.8 to 0.9, okay, there is a concern. You have to be aware, okay, berhati-hati. Okay, but if more than 0.9, totally terus eliminate one of them. Okay, another example. Okay, this one examples of intelligence and academic performance. Maybe intelligence and academic performance to predict quality of life. Quality of life of the children. Okay, when you do the multicollinearity, the intelligence and academic performance shows very high correlated, 0.9 and above. So you have to choose either one. You want to choose IQ or you want to choose academic performance. Okay, alright. So to look at the multicollinearity in SPSS, you can detect by tolerance and VIF. If tolerance less than 0.1 or VIF more than 10, that means problems in multicollinearity. Okay, so no problem. You click. Okay, you can get the result of this multicollinearity. Alright, about outliers. Outliers also, okay, extreme cases have too much impact on the regression solution and should be deleted, rescored, or the variable transform. Okay, to look at the outliers, in the multiple linear regression, you can look at the Cook distance or Mahalanobis distance. Okay, so this also I can show you in the SPSS lab. Okay, maybe next week. I not look at the, I don't know the timetable. Okay, if high, look at data view, get rid of that high value cases. It shows that, okay, from 100, okay, the samples, the respondent number 50, it shows that this is the outlier. So for multiple regression, you delete that item, delete that subjects only for multiple linear regressions. Okay. Two predictors should not be higher than 13.82. You have three predictors should not higher than 16.2. Okay, if high, look at data view, get rid of that high value cases. Okay, so between R or R square. Okay, so R just give value of strength or relationship, but the R square are more relevant because it tells us how much variations in the dependent variable can be explained by the predictor variables. Okay, for example, okay, just this is the repetition. Statistics of variation in the dependent variable can be explained by the variations in the independent variables. Okay, dummy coding. Okay, this is the case that your predictors, your independent variables are not continuous. Okay, are not continuous, but it is dichotomous. Okay, dichotomous, for example, females and male. So, okay, but you have two coding. This is the dummy coding. Okay, dummy coding, you code 1 and 0, not 1 and 2, but 1 and 0, 0 and 1. For example, females 0, males as 1. So you can interpret a subject who is male has the code for males equal to 1 multiplied by the regression coefficients for gender. If you want to predict females, when you times with 0, of course 0. You don't, not plus or minus. Okay. If that you insist of I want to include race or ethnic, where it has 3 categorical group. You insist you want to check that as your confounding factors. You want to control that for race. Okay, you can, but also you have to do the dummy coding. Okay, you record for Malay. For the variable Malay, 1 Malay, 0 non-Malay. Chinese, 1 Chinese, 0 non-Chinese. Indian, 1 Indian, 0 non-Indian. So you have three columns. One columns for Malay, non-Malay, another one Chinese, non-Chinese, another one is Indian, non-Indian. So in your equation, it will be like this. Y plus A plus B1 for Malay plus B2 for Chinese plus B3 for Indian. So if you want to predict the Malay, okay, so when you want to predict Malay subject, okay, so you can include 1 here, Malay. So other one, the Chinese 0 and Indian 0. So your equation will be for Malay. So you have to make sure do the dummy coding. So in your thesis, make sure if you are using this one, this have to be explained, to be right in the maybe table in your thesis. Okay, this is how you write. This is how you code the dummy coding in the SPSS. Okay, subject 1. Race Malay, Malay. When your subject is Malay, so this is Malay 1. This is 0 for Chinese and Indian. For Chinese, this is 0, 1 and 0. Okay. And the scenario, the example of scenario for MLR. A researcher choose 1,000 male subjects engaged in sedentary occupation. He wishes to study relationship among risk factors in this population. Okay, the variables are Y, oxygen consumption. Okay, so this is all the independent variables. Systolic blood pressure, total cholesterol, HDL cholesterol, TG, So these all the independent variables or predictors to predict the oxygen consumptions. Okay, that number has nothing to do with lottery. That is your cholesterol level. Allah banyaknya. Okay. Example 2, a study investigates the relationships between stress and certain other variables. Okay, data were collected on a simple random sample of corporate. If your dependent variables measure of stress, your independent variable can be measure of firm size, number of years in present position, your annual salary, your age. Good. So this is your independent variables. Okay, this is the example of PSS. Okay, I'm sorry because I'm using the very old version of SPSS for these examples. Okay, so I will try using the new versions of SPSS. After that, I will upload the new lecture notes with the new version of SPSS after this. So for today's lecture, I will show you the old one, the old versions. Okay. Alright, so researcher would like to find out how competitive a worker is by looking at 3 predictor variables such as IQ, knowledge on sports, and his English vocabulary. Okay, so nampak? Oh, very old versions. Tak tahulah 14 ke 16 ke. Okay, so this is the competitiveness of the respondents. Okay, this is their IQ. Okay, this is the sports knowledge and this is the vocabulary. Okay, so what you need is more than 2 columns of data, more than 2. So this is 1 dependent, this is 2 or 3 independent variables. So here we will predict how competitive someone is rated by their IQ, how many minutes of sport they perform per week, and a vocabulary score. Okay, if you have many variables, you can include or exclude them depending on your theoretical basis. Okay, this is the importance of your conceptual framework. Okay, your conceptual framework, when it shows that okay, this influence, this influence, this influence, this also, that one, from there that you can manage that or which to include, which not to include. Okay. Alright, so here analyze regression linear, same with the simple linear. Okay, same in here also, but dependent ones, the independents have 3. You put all the 3 in the independent variables. Okay, so the predictor. Okay, so there is statistic, plots, and save. Okay, just click OK. In here, I just give you the methods for enter methods. This is the result of enter methods. Okay. Alright, same with the simple linear regressions. They show you the R square, adjusted R square, but important is your R square. The proportion of variance that can be predicted by the regression model using the data provided. 0.9, 90%. Wow. Okay. And the significance here in ANOVA result shows that the models significantly can predict the competitiveness of a worker. Okay, the whole of the equations. SP operators are significantly enough to predict dependent variables. Okay, should be normally be reported like this one. Right. Then this is the important table to extract your this one, your equations. Okay, Y is competitiveness. Dependent variables Y, right? Y equal to 93.438 plus this one. If it seems like 5.464E. This is not error. This is not error, but it means equal to 10 kuasa 2, 10 square. 10 square. Minus negative here. So this means 0.05464. Okay, IQ plus, this is negative 0.357 spots, and plus 0.376 for vocab. So this is your equations where the strength of this equation is 90%. So you can propose, if this is the result from your study, you can propose this to all the company. Okay, all the human resource. Okay, if you want to search for new workers, okay, this is the model. Okay, if you want this model, you have to pay me 1,000. Yeah, if you want to make money with your result of your thesis result, so you can do that. Okay, apa ni? Alright, so what you have to look at? So there are many information here. Very rich information here. Okay, number 1 is this one. Okay, from B you write the equations. Okay, number 2, look at here the SIG value. Okay, from all the three, the independent variable, which one is significant? IQ, spot, and vocabulary. Which one is significant to predict competitiveness?
Vocab.
Spot.
Yeah.
vocab.
Yes. Yes. Vocab and spot. IQ, no. So you don't need to check their IQ. They're genius ke, they're not genius ke, that's okay. Not significantly can show that you are competitive as a workers in the company. Okay. But what important is the sports knowledge and the vocab. Okay. So we have dapat dah gambaran kan? Okay. Okay. So we have 2. Okay. Now look at the unstandardized. Okay, look back at the B value, the significance. Okay, the significant spots and vocabs. Okay, which one is positive, which one is negative?
Vocab positive.
Okay, vocab positive, spot negative. Okay, in here, so you can predict that, oh, so those with vocab will increase the competitiveness if you have high vocab. But for sports, negative. Okay, if negative, the more spent times in sports, the competitiveness will be low. So it's because this is negative. So when you ask the human resource they can ask, okay, how many times in a week you spend in your sports. So from that result, they key in the data. They will show you, oh, this is if the times is only 150 for the physical activity as a normal person, okay, that's okay. But more than that, maybe not 150, but 1,000 minutes per 1,000 or 2,000 minutes per week. Okay, so this will give you lower result for competitiveness. So you got the significance here, you got the positive negative here. Okay, the other one is which one? You know this is not important, not significant. IQ not significant, but spot and vocab is significant. Okay, which one from spot and vocab is the highest? Give the highest correlation, the highest influence. Okay, look at the standardized coefficients of beta. Okay, look at the beta. Okay, so which variable shows you the highest values? Is it
Vocab.
spot?
Vocab.
Yeah, it is vocab. So vocab 6, spot 5. The lowest IQ. So vocabs is the highest one. Gives you the highest influence for your competitiveness. This is the highest one. Then followed by sports. Then followed by IQ. Okay. Alright. So, standardized beta coefficient show the contribution that individual variable makes to the model. Note that the largest influence on competitiveness is vocabulary. Sport is second but negatively correlated. And IQ, small contribution in predicting competitiveness. Okay. Alright. T-tests are performed to test two-tailed hypothesis that B-value is significantly higher or lower than 0. Vocab is significant, also significantly negative. Okay, so any question from these examples? Is it okay?
Doctor.
Yes.
In your the previous slide, you go back a little bit.
Mana?
One more. So, this one. It would be normally reported as F bracket 3 and 3,62. Where do we get this number?
Okay, this one from the ANOVA table. Regression 3, residual 6. This is the F18. This is the P.
So that is the upper style reporting.
I apa style rasa I kalau apa style saya tak letak benda ni. This is maybe for your thesis. For thesis kan maybe you want more precise, more complex data reporting kan. Maybe you want to report the ANOVA, then this one. But in the journal APA style, maybe you don't need this one. What you need is the result of these coefficients, these tables, the R square and these tables. Okay. Alright, so this is examples. This is SPSS, not the latest one, but maybe SPSS 22, I think. Okay, marketing manager of PetSmart wanted to determine the effect of shelf space and price on the sales on pet food. So the sales is your dependent variables. Independent is shelf space and price. So this is the independent variables of your predictor, shelf space and price. So 15 branches selected. So they measure the shelf space, they determine the price per kilogram. Okay, then they key in. Right. So the price and space inside the independent variables. Okay, dependent variable is sales. Okay, this is what look like when you click the statistic here. Click statistic. Okay, this is what appeared. Okay, you check for estimates, model fits, and check for case-wise diagnostic, outliers outside 3 standard deviations. Okay, check this one to check for residuals and click continue. Okay, then this is what appears when you click the plots. Okay, so click a plots. You from all these variables. Okay, the Y is Z residual, X Z predictors. From here, Z residuals, Y X Z predictors. Okay, normal probability plots. Alright, then okay, this is the scatter plot. Right, the scatter plot, look at the 3 standard deviations, only 2, 2, 2. Okay, so just no outliers. No clear relationship between residual and predictor values. Okay, so you can proceed. Alright. This is happens when you click save. Okay, save. Okay, this is what you need to click Mahalanobis. If you remember the multicollinearity, okay, check for Mahalanobis and Cooks. Alright, so continue. Okay, this is the results of Mahalanobis distance. Okay, there are many standard error lah apalah. Okay, look at mahal. Mahal. Okay, mahal in here in Malaysia means expensive. But this is for the short form of Mahalanobis distance. Okay, mahal distance. Look at the minimum, look at the maximum. Okay, when the maximum is 5.47, okay. If you look at the table that I show you, if you have two predictors, if it is less than 13, no multivariate outliers. So there are no problems of outliers. No multivariate outliers. If this is still less than 13. So you don't have to look, you don't have to delete variable, omitted, not variable, delete subjects, omitted subject. You don't have to do that because there is no outliers. Alright. Okay, other than that, what I want to show you, okay, this method, there are many methods. Is it enter, stepwise, remove, backward, forward, okay. So if you choose enter, the SPSS will calculate all the significant, not significant, and they will give you all the equation, whether it's significant or not in your model. They will include in the normal on significant or not significant. This is the examples of the first examples about competitiveness with IQ, with sports and the vocab. I use enter. When use enter, the IQ is still inside there. Okay, but in case of your thesis, you have 1,000 banyak sangat. Okay, you have 100 variables, independent variables. So if all is if you use enter, method enter, then you have to plus all the variables, plus 1, plus 2, plus 3, plus until 100. Okay, so it be good if you choose the stepwise. Stepwise, the SPSS will calculate only the significance model, the significance variables in your model. Maybe from 100, the significance is only 5. So your model, your equations, only 5 significance variables. Okay. Other than that, I think backward, forward also will give you the significance. But the way they do the process of putting the significant or not significance is different. For example, if it is forward, maybe from all 100, they will analyze and omitted the not significant one. They will omitted not significant 2. It will forward, but from backward is from small, from only maybe 1. They will add. But for stepwise, it is you enter. Dia macam better stepwise lah. I think it's very hard to explain. It's better for you to use stepwise. The more way why is it stepwise, you search sendiri. Very hard to explain. Okay, so you better choose to enter or stepwise. Penatnya. Okay, summary. Alhamdulillah. Okay, summary. Okay, this is the step. Okay, first, make sure you know what is your research questions. Is it the research question that I showed you before? This can predict this, or you want to control this. Okay, for this example, do the cost of rent influenced by the family income and percent of population change? Okay, step 1, you can state the null and alternative hypotheses. For example, hypothesis null, family income and percent of population change are not associated with cost of rent. Hypothesis alternative, these independent variables are associated with the cost of the rent. Okay, step 2, determine your alpha. Okay, by default it is 0.05. Your alpha level 0.05. Step 3, make sure all data meet all the necessary assumptions. All the sample size, outliers, multicollinearity, the homoscedasticity. Make sure this is met. Okay, step 4, examine the statistical significance of overall models. This is the F value from the table of ANOVA. Step 5, determine the overall variations in the dependent variable. This is explained by the R square. Look at the R square. Okay, number 6, obtain the regression equations. Okay, so y equal to constant plus this one. Okay, step 7, determine the relationship between each independent variables and dependent variables. Okay, in these steps, you can write which one of predictors is significant, and you can write how many unit increase or decrease, outcome of unit, all other conditions held constant. Okay, step 8, determine relative strength of the association of each independent variables on the dependent variables. 9, predict the value of dependent variables. 10, provide a summary of the findings. Okay, this is the summary. The multiple linear regression model predict 10% of the variance in percent of rent. This is statistically significant using F-test. The independent variables that are significant predictors of the dependent variables of alpha 0.05 are family income and percent of population change. This is very brief summary. Other than that, you can include the equation, you can include the increase or decrease of units. Okay, the end. Aduh. Okay. Any questions? Saya dah penat macam kucing ni dah. Okay. Okay, highlight. Okay, what insight you gain from these lectures? Alright, everybody. Still motivated after 2 hours plus?
Dr. Sharifah here.
Yes, Sharifah.
I just want to check again my understanding. In multiple linear regression, the row squared, the R squared is written in the capital letter.
Yes.
In simple linear, is written in the small caps. Is that?
Same.
Same. It's the same. No difference between the simple linear regression or in the multiple.
Same.
Okay, I thought there's a difference. And then in the SPSS check box just now, when you check the statistics box, there's a lot of box to check and uncheck, right?
Yes.
What happen if we accidentally check this and that? I mean, not following your instruction just now. I mean, accidentally check so many things. There's so many boxes there, right?
Okay, you can check. Oh, but we will make you pening lah nanti.
Oh, so that's the most
So
important thing
many.
only. Oh,
Then because if you check everything, then the result, the output will be very heavy of results.
and then the 3 standard deviation is like a rule of thumb, or we can put it like 2 or 4 or 5.
I think rules of thumbs. Outliers of more than 3 standard deviations.
Okay. And one last one, I miss where you check the mahal whatever just now.
Okay, here. Save.
Okay.
Nampak
Yeah.
Save, you click save here.
Okay.
Okay, and then distance Mahalanobis.
Oh yeah, alright.
Cooks and Mahalanobis. Okay.
So the reason why we must check the Mahalanobis and Cooks is to see either the 13 of something just now. It must it always 13 or something?
Yes, 13.8.
It is a rule of thumb as well.
There is a cut-off point. The cut-off point of for the Mahalanobis. I've shown you this before. Yeah, this. You have 2 predictors, should not higher than 13.8. If it's 3, 16.2. If you have 4 predictors.
Oh, okay. Right. So this one must be handy when you're doing this statistic test.
Yeah.
Okay.
Actually, if you have the book of Allen book, SPSS, okay, this is inside that book.
Allen, how to spell, Doctor? Sorry.
Allen.
I will find.
Okay. Okay, Sharifah. Okay, other than Sharifah? Masalah? Kan saya stop sharing. Ramai jawab tadi. Okey, bagus. Okey, ada soalan ke? Oh, siapa ni? Okey, tak ada. Kasmawati, okey, thank you. Oh, okay, thank you. Muntatir Habib. You can now have your breakfast. Sanjay also, you can have your breakfast after this.
Hi, Doctor.
Hi.
Shantini here. It's about like our previous class that we talk about sample size calculation of multiple regression. So like I still don't understand like how you want to know the power G calculation odds ratio.
Oh, okay. You have studied the manual G power? You studied that?
Yes, Doctor.
Yeah. Still cannot search. Yeah, you don't know how to.
It's actually we have to find in our journal, is it the odds ratio?
Yeah.
Okay, Doctor. Thank you.
Okay. Oh, next class is 4 p.m. Oh, next class 4 p.m. Not 2 p.m. Okay, other than that, if there's nothing, thank you very much. Okay. Oh, if I'm wrong, I'm sorry. And all the good one is from Allah Subhanahu Wa Taala. Okay. And we can see again after this. Okay. Okay, bye. Thank you very much.
Thank you.
Thank you, Doctor.
Bye.
So, thank you.
Welcome.
Thank you, Doctor.
Welcome. Have a nice lunch. Okay, take care, Daya. Okay, bye. Welcome.